All right, example one. A particle moves along a line. Its position function is given by s of t equals negative t cubed plus 22t squared minus 105t. Find the times t when the particle changes direction. All right. Now, in the first video, we talked about velocity, including a speed and a direction. So whenever we talk about direction, that's the key word to think about velocity. That's something that needs to sink in very, very well, because you'll have to read this and then be able to say, oh, okay, I need to figure out when the velocity changes sign. The velocity changes direction when the velocity changes from negative to positive or from positive to negative. So either time that happens, those two things, then we know that the direction of the particle has changed. So first thing that we need to do is find a velocity function. Well, that's easy, because all we have to do is take the derivative of that. Because remember, the rate at which the position is changing is the same. That's the definition of velocity. So let's take the derivative and find the velocity function. So I'll be taking the derivative with respect to time, and that will give me my velocity function. So I'll just write v of t, and then I'll take the derivative of this. So the derivative, that's easy enough, just using power rule. 3t squared plus as 44t minus 105. And then we got to think about the next idea, and that's, well, if I'm going from a negative number to a positive number, I have to cross over 0. If I'm traveling like -2, -1, I have to hit 0 before I become positive. And then same with positive to negative. If I have 5, 4, 3, 2, 1, I have to hit 0. Then I can go to the negative numbers. So that's our hint. To change sign, the velocity has to become 0 right in between. Yeah?
Yeah, of course. That's what it makes sense. Let's find out when it's 0. Let's find out when the velocity is 0.
So that's what we're going to do. We're going to find out when the velocity is 0, because that's potentially where it's changing from negative to positive or positive to negative. We'll have to test it out, because it could be the case where the particle is moving forward, so it's like moving from position 0 to 1 to 2, and then it stops for a little bit, and then it continues moving forward. So it didn't change direction, although maybe it slowed down to like 0 velocity. But it has to go from negative to positive or positive to negative. It doesn't have to just be 0, but we're going to use the fact that if you're going from negative to positive, you have to pass through 0. Same with positive to negative. You have to pass through 0. So that's what we're going to do. Find out where the velocity function is 0. So we must find where the sign changes, and to do that we find where v of t equals 0. So that's all we have to do. We set it equal to 0 and solve, and it's just a quadratic. Isn't that beautiful?
Yeah, it's pretty beautiful. Do the problem.
All right, settle down. Negative 3t squared plus 44t minus 105. I factor a little bit differently maybe than you do, but let's try and factor this. Oh, that's a nasty one, isn't it? All right, this might take me a little bit, but let's try and factor. First, 3 times negative 105 is 315, and we want it to add together to be 44. This is going to be a toughie. I might struggle with this. What times what gives you 315, but when you add them together, you get 44? I don't really know, so I'm just going to start doing multiples of 315, or factors of 315. 1 times 315, that's definitely not it. 2, that won't go in evenly. 3 and 105. I'm honestly just getting 315 and dividing it by numbers and seeing what I get. That's how I write out the factors. When it's huge like this, I'm just going to do it systematically. That's how you can do it too. Or you can do it in a calculator. There's a function that does it. That solves these. Maybe I'll teach you how to do it. Yeah, I think it will. So divide by 4. Does it divide by 4? No. Divide by 5. That's 5 and 63. Hey, we're getting close. What about 6? No, if it was divisible by 6, it would be divisible by 2, wouldn't it? 7, divisible by 7. That would be 7 and 45. If I add those together, it doesn't work. Okay. Divisible by 8? No, by 9? Yeah, I think so. 9 and 35, that adds to 44. Okay, there we go. Those are our two numbers. That's how you can figure that out. It doesn't take that long. But if you have a graphing calculator, there's a function that allows you to just solve. You just have to guess. I'll show you how to do that. So, we factor. This is the way I factor. You factor however you do it. But I have 3t squared plus 9t plus 35t minus 105. Group them up. I can take out a negative 3. Oh, that's weird. Negative 3t. And I'm left with, what? T minus 3. And then on this part, I can factor out at least a 5. Actually, I can factor out a 35. Yeah. So factor out a 35 is a positive 35. I'm left with t minus 9. No, t minus 3? Yep. So there we go. Those are the same. That's what I wanted. So I really get negative 3t plus 35 and then times t minus 3. Cool. And that's still equal to 0. So I can like flip them around. T equals 3. Also, maybe I'll just set that one equal. You set each piece equal to 0 and solve. So negative 3t plus 35 equals 0. This is called the zero product property. Maybe you learned it in Algebra 1. You should have, at least. And t, if I just move stuff over, t would be positive 35 over 3. So these are the spots where the velocity is 0. We're still not done yet. This is a tough section. And we're only doing one problem per video. Jeez. So, well, the velocity is 0 when t equals 3 and when t equals 35 over 3. 35 over 3, what is that? Approximately 11.7. We need to see if the velocity goes from positive to negative over these values. So I'm going to do a sign chart. These are actually called critical points when the function equals 0. Or when the derivative equals 0. These are critical points. But anyway, this is how I set up a sign chart. I get my critical points, and I write them in the top. So 3 and 35 over 3, which is about 11.7, just so I know. And then I draw lines down, I make a chart, and then I have test points. TP is test points. Maybe you write that down. I'm not going to write it down. So I'm going to pick some test points that are on the left side of 3, and in between 3 and 11.7, and on the right side of 11.7. What does that mean?
It just means you should pick a smaller than 3 in the middle of those two numbers, and then bigger than 11.7. That's all you do.
Okay, so my test points, I'm going to choose 1 is an easy test point, and it's smaller than 3. Sweet. Maybe 4 is another test point. It's between those two, and then 12. So those are my test points, and then I'm going to plug it into v of t. So I need the sine of v of t, and I'll plug these into v of t, which is that, or in its factored form, it's just this factored form. You can plug it into either one, but what do we have? If I plug in a, whoops, that should be blocked off. If I plug in 1, what do I get? Well, that would be, if I plugged in 1, negative 3, so 35, 34, 32. That would be positive 32, and then this would be just 1 minus 3, that's negative, right? So it's a positive times a negative, that'll give me a negative. Okay, so that's a negative value. Okay, if I change, if this is positive, then 3 is a time where the particle changes direction. That's what I wanted to know. This is a lot. It takes a long attention span to do these problems. Plug in 4. What happens? Well, if I plug in 4, what I get? 12 here, negative 12. This is bigger, so this will be positive. And then plug in 4, this will be also positive. Positive times a positive is a positive. Sweet. Because really, I'm only concerned with the sign of v of t. And then plug in 12 and see what we get. And what is it? Plug in 12, that's negative 36. Plus 35, that's a negative 1. And a 12 minus 3, that's a positive. And it also changes sign, because a negative times a positive is a negative. So it changes sign there, and it changes sign there. Shoot, that means t equals 3 is where the particle changes direction, and t equals 35 over 3 is where the particle changes direction. That's it. That's the end of the problem. Geez, this is a long video. Sorry. Goodbye.